Hello all, good day. Welcome to Distributed SQL Summit 2025. This is Hariprasad, Senior Solutions Architect with APJ Field Team. I'll be walking you through the topic architectural flexibility and geo-specificity with cluster-to-cluster replication. This topic is increasingly relevant in our world of global scale applications and evolving regulatory landscapes. Yugabyte's xCluster feature enables robust data resiliency across regions, supporting planned switchovers, unplanned failovers, and active-active deployments. Whether you're navigating through a disaster scenario or orchestrating a planned maintenance activity, Yugabyte's xCluster feature ensures that your data is consistent across regions or clusters, thereby ensuring that your application is always on. Let's dive in deep, look into how xCluster achieves this through the next 30 minutes. Why do we need cluster-to-cluster replication? Let's go through a few of these scenarios that modern day applications face and look at how the cluster-to-cluster replication addresses them. The first one is all applications today need high availability, low latency. The applications expect their database should be ultra resilient, able to survive any sorts of failures, be it a region failure or a cluster level failure or infrastructure failure. With cluster-to-cluster replication, data gets replicated to a different geography or a different cluster, ensuring that your system survives or your database still serves your writes and reads, even in the case of a region failure or a cluster level failure. The second one is regulatory and compliance constraints. Nowadays, the regulatory and compliance requirements are too stringent. For example, the RBI guidelines in India or the European Union GDPR guidelines. Most of these regulatory and compliance guidelines dictate that your DR drill should be performed on a particular schedule, scheduled DR drill, for example, or they mandate that data should not be migrated beyond certain geographical boundaries. So in both these cases, this cluster-to-cluster replication meets the need. It replicates data to the selected geographies. The cluster-to-cluster replication brings in an active-passive disaster recovery setup where data gets replicated from your active side to your passive side, and the passive side can be brought up as your new primary in case of failures or during a planned DR drill or DR switchover activity. Multi-cloud or hybrid cloud strategies are often deployed to address resilience or organizational goals, which is again achieved only through cluster-to-cluster replication. In the case of systems that are deployed within a region, even though they have multiple availability zones, for example, let's take an example of a cloud deployment. A system deployed within a region with multiple availability zones are still susceptible to failure in case of multi-AZ failures or a complete region failure. This is where we need cluster-to-cluster replication, where data gets replicated altogether through a new region. Right? And coming to the last point, traditional systems do not scale nor they support automation. So we all know how the traditional DR setups are built, how the DRs is invoked. It's all through manual scripts, complex operational procedures. This xCluster replication ensures that your automation needs are met, your scalability needs are met. Let's look at that in detail in the upcoming slides. So before we get into detail on the xCluster's architecture and the types of xCluster options we have, let's look at some of the real world usage patterns. Organizations use xCluster for their DR requirements. Mostly DR requirements mandate minimal RTO and zero data loss or near zero data loss. xCluster meets a need in this case where in case of a planned switchover, the RTO is in minutes, very minimal, and the RPO is zero. And in case of an unplanned failover, say if your primary data center is fully down, we have to invoke a failover. And even in the case of complete failover, the process of invoking DR, the process to initiate failover, is completely automated and orchestrated through our Yugabyte Anywhere UI. The second point, systems demand active-active setups, or the systems that demand multi-region presence can make use of the bidirectional feature, which replicates data from, say, for example, cluster A to B and cluster B to A, thereby taking data closer to the users, reducing both their write and read latencies. The third point is the most important one: automated failures validated across regionally separated clusters. As highlighted in my previous slide, manual failures are very painful, time consuming, normally associated with a downtime and a very complex process. It adds operational overhead. Yugabyte xCluster helps you with automated and well orchestrated switchover and failover processes. Let's look at that in detail in the upcoming slides. Yugabyte can be deployed in multi-cloud environments, can be deployed in hybrid cloud environments, on Kubernetes, on VMwares, on on-prem systems. Can also be used for designing zero downtime migration strategies. Say, for example, you're migrating from your cloud environment to your on-prem system. You can still set up xCluster between these two environments, replicate data seamlessly, and on the cutover date, stop your applications, switch over the roles, let the cluster in your local data center be your primary universe, and start pointing your applications to your local data center. This ensures that the migration is seamless, which is operationally pretty simple compared to the manual migration models that people have been following in the yesteryears. Again, xCluster enables region local deployments. As I updated earlier, it takes data more close to the user, and xCluster also helps you in bifurcating your workloads. So reads can always be directed to your DRs, and writes can be concentrated on your primary cluster. This is just to ensure that your writes does not get affected with in case of a read heavy system. The latency for both writes and reads is improved in this case. Let's move on, look at xCluster in detail. xCluster, as we have been discussing, enables replication between two independent Yugabyte universes. Universe is nothing but a logical grouping of clusters in the sense of a primary cluster and one or more read replica clusters. So the replication here is only among the primary clusters. xCluster supports both unidirectional and bidirectional replication modes. Unidirectional replication mode is often referred to as xClusterDR or transaction replication. The replication here is asynchronous and happens at tablet level. As you all know, tablets are nothing but individual shards, or the table gets distributed into multiple tablets, and you have the val records associated with these tablets. Since the replication happens at the tablet level, the replication is more efficient and is easily scalable. Tomorrow, when you add nodes to your cluster, when you scale out, your xCluster supports the scalability factor efficiently. And xCluster comes with proper observability features. We do have this metadata synchronization, which ensures that the end user is able to monitor the cluster health both at the replication configuration level and at individual table level. Users can still monitor the replication lag at each object level that replicates data from your primary to the standby system. This ensures that they take a very mindful decision when they want to do a switchover or a failover, which is often associated with the minimal downtime or minimal data loss. The YBA setup and operations like monitoring, maintenance, switchover, and failover all can be facilitated through the YB Anywhere UI and the YB Admin CLI as well. Let's move on to the next slide. Let's look into the xCluster solution in detail. xClusterDR is the go-to-go DR solution in Yugabyte DB, which offers native disaster recovery capabilities. The data here is replicated in uni-directional fashion, replicated asynchronously between the clusters. This particular feature is ideal for active passive deployments where data gets replicated from your active side to your passive side. Active side supporting both writes and reads, and passive side supporting reads alone, and readily available for activities like switchover and unplanned failover activities, making it an ideal solution for DR requirements, regional failovers, and compliance requirements that require data localization or geo redundancy. The key highlight with xClusterDR is its simple, automated, and orchestrated failover and switchover activities, opposed to the traditional DR drills or DR invocations where there is a lot of complex manual overhead. You have to run manual scripts, follow through complex procedures to invoke DR. Let's look at an example that's highlighted here in this slide, where there are three transactions, T1, T2, and T3 happening in a particular order in the cluster 1. Two of the transactions, T1 and T3, reach cluster 2, whereas T2 is still at cluster 1. And when the user queries the target universe at this point, only T1 will be visible to the user, even though T3 is present, just ensuring that the transactions reach your target cluster in the same order in which they were committed at your source side. This ensures consistency at the transaction layer. Let's move to the next slide. How xClusterDR works, replication is set up between your primary universe and the target universe. Again, the primary cluster replicates data to the standby cluster in asynchronous fashion. Here, the replication happens at tablet level. Even though we do not replicate data directly from one tablet to the other, it happens through the val records that are associated with the tablets. Tablets are nothing but shards of a table. A table gets split into multiple shards. And since the replication is at tablet level, it ensures high efficiency and supports scalability as well when you scale out the cluster in the future. And xClusterDR offers observability options where it displays the replication lag at individual table level. You get to see the health of the entire replication stream. It displays the potential data loss in case if you want to fail over a system in the case of a region failure or a cluster failure. And again, as highlighted earlier, xClusterDR supports both automated switchover and failover option. In the case of failover, you get two more options, either to repair and add the existing or old primary to your cluster, or add a new DR altogether once the failover is achieved. And the most important thing is xClusterDR ensures consistency and low latency data replication. Consistency is again achieved through the order in which the transaction gets replicated to your target cluster. This is based on a parameter called xCluster save time. That is a point till which a transaction has been fully replicated to your target side and is consistent. This xCluster save time parameter plays a key role mostly or whenever you invoke a unplanned failover. Right. Okay. Let's look at the seamless DR switchover feature more in detail. When do we initiate a switchover? Whenever there is a planned DR drill, most of the regulators now want DR drills to happen every 6 months, where you switch over to your DR side, run your workload, send the evidence to the regulator, and then you switch back to your DC. This is one of the activities where we can reduce complexities at the database side, where the entire switchover and switchback activity is automated. You can couple these APIs, switchover APIs, with your automated application workflow, and we have customers doing it successfully. The second use case is whenever there are infrastructure activities where your primary site has to be brought down for a brief period of time, and you don't want your applications to be down even during that window. In that case, you switch over, do your infrastructure changes or your upgrades at your DC side while your application is up and running in your DR. Right? So how do we achieve this? Your standby gets promoted within minutes, and you can redirect your application connections to your target site through application connection string changes. Right. So it's again a one-touch option. Once the switchover option is selected, the system performs a complete health check, evaluates the replication lag. The replication lag should be as minimal as possible, checks the health check of the replication configs and other prerequisites. Once the prerequisites are done, the replication is set up in the reverse direction from your new primary to your old DC or your new standby. Then we do wait for the transactions to be completely drained out from your primary to your standby side. This is to ensure that there are no data loss associated with this switchover activity. Once the data is completely drained out, the old replication is removed, post which your application can connect to your new primary, and then the primary starts serving your reads and writes. Let's have a small demo on this, post which we'll move towards the unplanned failure part. We do have a xCluster disaster recovery setup where my DR cluster on AP South 2 is replicating data to my DC cluster on AP South 1. I know it's replicating data in the reverse direction. So let's try to do a switch back to DC and then check the behavior. So I'm initiating this switch over here. I have to give the target cluster name. So I'll initiate the switch over. So in this case, when the reverse replication is set, it does not perform a complete bootstrapping. That is, it does not take a backup and restore, as the data is already in sync between your DC and DR clusters. That means your switchover activity completes within minutes. As I said, the switchover is completed, and you could see that the replication has been reversed. Your DC cluster is replication data to your DR cluster now, right? And you can see the list of tables associated with this xCluster configuration and the lags that are associated with each of those tables that are being replicated. Okay, so let's move on to the next slide, which is unplanned failover. Let's move on to the next slide, that is unplanned failover. Few scenarios where we initiate unplanned failovers are your primary data center or your primary region is fully down, or you do face critical issues at your primary side because of infrastructure issues, your disk slowness, or your network partitions, and you want to have your database switched over to your DR side and want it to be up and running. So in that case, we make use of this failover option. And the caveat here is, any DR notification is always associated with minimal data loss. In Yugabyte, we do display the potential data loss that could be resulted based out of this failover task when a user initiates the failover, and that potential data loss is totally or it's connected to your replication lag. If your replication lag is minimal, your potential data loss is going to be as minimal as possible, and you're just going to lose your in-flight transactions that were hitting your primary cluster during the issue occurrence timestamp. Let's have a small demo. I'll take you through a couple of options that we have in this unplanned failover task. So one of the option is to repair your old primary and attach it back to your xCluster configuration once the failover is done, or create a new cluster and then set up xCluster application among those two clusters. This is again one touch done or orchestrated by the Yugabyte Anywhere UI. Let's go through the demo. So we are back to the same cluster again. I have my DC cluster replicating data to my DR cluster. So you do see this field highlighted over here, potential data loss. Right now it is 774 milliseconds. So when I initiate the failover, the same notice is being displayed here that I could potentially lose 8-10 milliseconds of data if I initiate my failover. So I'm initiating this failover. Yeah. So under the hood, once your primary data center is down, and it's always advisable to stop application traffic to your primary data center to avoid transaction declines. So, and once we initiate the failover, we have this potential data loss calculated. That is based on the xCluster safe time. That is the point to which the transactions have been fully replicated and are in consistent state. So the system will perform point in time recovery till the xCluster safe time point, which means that your data is again consistent. Whatever data you had in your primary side till the consistency point will always be recovered at your DR site as well. And point in time recovery in Yugabyte does not involve any primary data movement. So all it does is restores the periodic timestamp and does a flashback to your xCluster timestamp, which is way quicker than the traditional data recovery methods. So we have initiated the failover. Let's check the status of this activity in the taskbar. Sure, DR config is completed successfully, and that is reflected here as well. The DR cluster does not have a component, DR component, and the replication configuration is unconfigured now, and you could see that from the table states as well, the replication status of the tables. So once the failover is successful and your DR cluster is has started taking the application workload, you have two options: either to repair your old DC cluster and add it back to the configuration, or switch to a new cluster and then configure it as your new DR partner. So let's try both of the options. In this case, I'm trying to reuse the current DR replica. So this will go through a complete bootstrapping process where backup will be taken from the current primary and restored it in your DR side, and then the replication sync will be initiated. So let's try this. So let's check the status in the status bar as where we are now. So as of now, the restoration at the target is in progress, and this should complete shortly. Yes, adding the old DC to the cluster is successful, and you could see that my DR is replicating data and DC is receiving data. The tablet status are operational and the lag is 0. So let's try to simulate adding a new cluster again uh, after simulating the failover. So I'm initiating the failover right now. Yes. So my failover is complete. My DR cluster is marked as failed. My DC cluster, my primary cluster does not have a DR component as of now. So I have to add a new universe as DR replica. So I have a pre-built DR cluster in this case. So I'll select the DR replica, new DR replica. I'll initiate the repair. This will again go through the same bootstrapping process of backups and restorations. Let's go to the taskbar to check the status. Yes, you do see that bootstrapping will be initiated, followed by backups and restore. Yes, the DR configuration activity is done, and you could see that I have my data getting replicated from my DC cluster to my DR cluster new. That's it with the demo. Let's look into the bidirectional replication feature in the next slide. Bidirectional replication. In contrast to the xClusterDR feature that we were looking into, bidirectional replication enables read-write operations in both the clusters, making it a active-active system suitable for globally distributed applications where users can perform both writes and reads uh, to their closest region, thereby achieving low latency in terms of both writes and reads. And this system can serve uh, region level supports region level availability. In case a region completely goes down, the other region can take up the application workload. More suitable for workloads that need regional autonomy and write flexibility. Let's look into the xCluster feature in detail. This is this particular architecture is built using two unidirectional replication streams from cluster A to cluster B and from cluster B to cluster A. Both clusters taking up writes and reads, and the underlying replication strategy is same as that of xCluster replication, where data replication is handled at tablet layer using the val records. Both the universes can concurrently take writes and reads, which could pave way to uh, conflicts, and that is resolved by Yugabyte using the last writer wins, which uses timestamp ordering to find out the last committed transaction, and that particular transaction will be sustained in both the sides. And the read set, the target set, always follows read committed isolation just to ensure that people do not read stale data or partial data. And to the last slide, what next? Automatic DDL replication is the next big thing in this particular feature, where users can just create tables, alter tables, create indexes, or perform DDL operations at the DC side, and the DDL changes get seamlessly replicated to the DR side. Do note that the cluster management, xCluster management is at the database layer, and any change that you do to the objects get seamlessly replicated to the DR. This particular feature is available in our preview versions 2025 and 2.25. And will be available in the next LTA versions pretty soon. Having said that, we do have semi-automatic xCluster feature where users should be creating DDL changes at both source and target, and it automatically gets added to the xCluster configuration. Hope you had a good session learning things about xCluster feature in Yugabyte. And that's all I have for this session now. Thank you.